Okay, hi everybody. Today we're going to go over an intro to the Python game Kessler that we're using for the competition this year. We'll go over details on the game itself, how to instantiate games, create scenarios, create controllers, etc. And we'll actually dive into the code a little bit. And then we'll talk about the milestone requirements. The milestones are mandatory, and we'll talk about those at the very end. But we'll go ahead and jump into this. So Kessler is an open source game in Python. I should mention that we have our XFC website that has been updated for this year. We also have our Slack, which I'm going to keep advertising as a way to keep in contact with everybody in the competition and the organizers, besides email, and our YouTube channel, where we are uploading not only the seminars that we'll be going over, but also recordings of things like the competition later on, and any of the help sessions. And you can go here and view the seminars and recordings from previous years. So what is Kessler? It's a game inspired by Fuzzy Asteroids and Asteroid Smasher. Asteroid Smasher is a open source Python arcade game. So if we actually go to, oops. So this is an open source game, which was the original game that we used for XFC. You can go see the entire source code here. But it was not developed with machine learning in mind. So we rewrote it and created Kessler in order to be more stable and to be more efficient for machine learning and reinforcement learning. The interfaces haven't really changed, and we have different graphics options, including tkinter and Unreal graphics options. The default are these tkinter graphics, which are relatively basic, but pretty easy to use. You don't have to do anything to get these up and running with the game. The downside is that besides being basic and not the prettiest thing to look at, it is somewhat slow to render. It's relatively inefficient. The Unreal graphics that we have is a bit more involved in getting that set up, but we can help anybody that wants to get that going. They do look a lot better, although there are definitely improvements to be made. There's also some other fixes we need to add in for things like mines, but we'll most likely be doing that due to reasons I'll talk about a little bit later. For installing Kessler, you can go to the repo and just grab the code directly if you'd like. You can find that here and look at also some example code that's on there. We're also happy to have people submit issues and help us improve the game, and if you identify bugs or anything like that. Previous competitors have been a big help in identifying those bugs or potential bugs and identifying fixes and just improvements in general to make the game more efficient. To install Kessler, you can either grab the code from there, or it is actually on PyPy, so you can just pip install it. If you look on the repository, let's pull it up right now. On the repository, there is this source folder and then also a bunch of other code, associated code. The source folder is the only thing that gets installed from PyPy, so you'll just have the actual game-related code itself, not the external code. Just keep that in mind. One thing to note is that Kessler currently requires Python 3.10. That may change in the future, but currently that is what it requires. These are some changes that were implemented a long time ago when we moved to Kessler from Fuzzy Asteroids. One thing I want to highlight is that the asteroids are deterministically split. So when you shoot an asteroid and it splits into the smaller child asteroids, they split such that the angles are deterministic. They're the same. We now do have an option such that those are random within a bounded range. but the default is that they are deterministic. And so any run of Kessler, given the same inputs and same controllers, will be deterministic. Unless you turn on the option for the non-deterministic splits. Each parent asteroid splits into 3 children. One has the same trajectory as the parent, and the other 2 are at an offset angle on either side. I believe right now that's at 15 degrees on each side. But again, that's in the code, and that is subject to change, but we'll make sure everybody knows that if it is changed. And momentum is transferred to the asteroids from bullet and ship impacts, and it's an elastic collision. So if you slam into a smaller asteroid, let's say a size 2 asteroid, with your ship traveling at max speed, it will impart that momentum on the asteroid. For the ships, we can have more than 2 teams, but we will be limiting the competition to only 2 teams at a time in each game scenario. Again, that could change in the future if we want to do like a battle royale style, but currently we're just doing 1v1 for any given scenario. So a bit more about the structure itself, and then we'll switch over to code. Screenshots aren't the best, but where you're going to start is taking a look at your controller structure. So there is this class called Kessler Controller in the game, and this deals with processing the game state information and returning an action to your ship. So this is actually how you control your ship. So you are going to create a child class that inherits Kessler Controller, and then takes in the information, performs some sort of actions, and then outputs the state for the ship. And the state for the ship, well, let me go over the inputs. The inputs are the ship state and the game state. So the game state includes all the information about the asteroids, bullets, mines, everything else that's in the game. And ship state is related to the ships themselves. The outputs that you're sending back to your ship are the thrust, turn rate, whether to fire a bullet or not, and actually, it's got left off, but whether to drop a mine or not. The firing and dropping mines are just booleans. The thrust and turn rate are floats that are within some bounded range. The game state information that you're getting back this immutable dictionary. So you can't change anything in here, but what you're getting is the asteroid state for all the asteroids, the ship state for all the ships, the bullet states for all the bullets, mine state for all the mines, other various information like the size of the map, the current time in the sim, the time step size, the step of the sim that you're in. So this is the frame, the integer numbered frame of the simulation, and then also the maximum time limit of the scenario that you're in. And so you can use any and all of this information to perform the actions that you need to with your agent. For ship states in particular, you get quite a bit of information, including if a ship is respawning or not. And by respawn, we mean there is a time after a ship loses its life where it is invincible. We call them invincibility frames. And that's to prevent, dying immediately. If you get hit by an asteroid and it splits into smaller asteroids and your ship is in the same location, well, you would just die immediately. So we give invincibility frames such that the ship can maneuver away from the current situation and then resume, shooting asteroids. You also get position and velocity info. You have speed information. You have heading information, the mass of the ship, radius. This radius is also what is used for the collisions. So anything within this radius is considered a collision. So if an asteroid passes within this radius of your ship, or another ship passes within that radius, that is how we determine if it, quote unquote, hit your ship. Same for mine blasts. If you're within the blast radius of a mine and it is within that radius, it will take a life or constitute a hit on your ship, I should say. We also have ship IDs, the team that ship is on, and the number of lives remaining. We also have additional properties that are only available about your own ship. So you can only get this information about the ship that you're currently controlling. You can't see this information about the other ships in the game. And that is things like the number of bullets remaining, if there is a limit on bullets, the number of mines remaining, whether you can fire currently, the fire rate of that ship. That's a constant currently. It's the same for all ships, but that may change in the future. Can deploy mine. That is just whether you, there's a cooldown period after you shoot and drop mines, and they are different for bullets and mines. But what that means is you can't fire bullets every single time step. There is some delay for when you can fire bullets and when you can drop a mine. We also have the thrust range, the turn rate range, the max speed, and drag, which it is a bit funny that we have drag in this quote-unquote asteroids game. We're supposed to be in space, but it makes it more interesting, I would say. Asteroid state, so what you get back for each asteroids, you get their position, their velocity, their size, and this is an integer from size 1 to 4. So a size 4 asteroid, if you hit it, will break into 3 smaller size 3 asteroids. And a size 2 asteroid, when you shoot it, will break into 3 size 1 asteroids. If you then shoot a size 1 asteroid, it is deleted from the game. That asteroid no longer exists. There is no size smaller than 1 currently. You also have the mass of the asteroids, which their mass does scale with the size of the asteroid. And their radius. So you can use any of this information to do whatever processing you would like. We have talked about some changes to Kessler, including things like sensor noise. And this would be notionally similar to an onboard radar if we implement it. So it might change a little bit what the information you're actually getting back from the asteroids. But we'll be very clear about how that's different from this if we implement that. We also have bullet states, which are simply position, velocity, heading, and mass. And bullets are low mass. They have currently have a mass of just 1 unit. Mines, you get their position, their mass, which currently doesn't particularly matter, their fuse time and remaining time. And so fuse time is the overall time of the fuse. So right now it's set at 3 seconds. It's just a constant for all mines currently. And so every mine that you place will have that same fuse time. The remaining time is the remaining time before it detonates. Okay, so how to actually use Kessler. So first you have to define a scenario. So this is defining the initial conditions for the asteroids and ships. And also things like if you have limits on bullets, the number of mines, etc. To instantiate a game, we have both normal game and trainer environment objects. The differences for these, the main differences are just in the game settings, which we'll see when we hop over to the code. But the trainer environment inherits from the game class, and it just sets default settings to run, as fast as possible and without graphics, things like that. More useful for machine learning. There's also a score class. This is actually giving you the score information at the end of the game. And so this is based on teams, and you will get a list of scores for each team based on the ID. So defining scenarios. I don't want to spend too much time on the slide. We'll just go take a look at the actual code. But the main things here are to see what you actually are defining. So what we're defining is the name of the scenario, the number of asteroids. This is an optional input. If you define this, if you pass this, it will randomly create that number of asteroids with random initial conditions. Asteroid states, also optional. You have to have one or the other, though, because if you don't have number of asteroids, what you will do is you will have to define every single asteroid and its initial conditions for that scenario. So instead of having randomly generated asteroids, you could place asteroids wherever you want with some initial direction and speed, we'll say. We also have your ship states. This is optional as well. You can have this or not. I believe the default behavior, we'll double check, but I believe the default is it'll place it in the center. You can define the number of ships as well. The game map, this is using the map object that is defined before that. And then also we have seed. This is if, because there are certain RNG elements in the game currently, you can seed it if you need to see the same behavior for a given scenario run. You can also specify the time limit. I believe the default is 60 seconds, but you can specify anything in seconds here. And also ammo limit multiplier. This is an optional flag for limiting the number of bullets each ship will have. And what this means is that based on the asteroids that you instantiate at the beginning of the game, there is a total number of possible asteroids if all of them are split into the children asteroids. And so an ammo limit multiplier of 1 means that you will have the same number of bullets as the potential number of asteroids in a scenario. So imagine I start out with 20 size 1 asteroids. They can't split into smaller asteroids, so the total number of potential asteroids is just 20. And so if I put the ammo limit multiplier at 1, I will have 20 bullets to start the scenario. If I put the ammo limit multiplier at 0.5, I will have 10 bullets. And same for 2. If I put 2, I'll have 40 bullets. And I should say that each ship gets that same number. So even if I have 20 asteroids and I set that at 1, every ship will get 20 bullets. We also have stop if no ammo. What this means is if all ships are out of bullets and mines, it will end the scenario right then. Otherwise, it will continue up to the time limit or until all ships are dead. Some other stopping criteria. Okay, so this is how we actually define scenarios. Actually, now is probably a good time to just hop over to the code because this is all getting into how we actually set up these example scenarios. Before we actually look at scenarios, I'm going to first go to the test controller. So this is the code that is on the repository. If you go to the examples directory, I'm going to go back to the repository real quick. So if you go up to this examples folder, you can see all of these things, all of these scripts and example files for creating controllers, scenarios, and then running games in Kessler. So what we're going to do for our test controller, from the game, we're grabbing the Kessler controller class. And we are then going to make our own controller called test controller, and it inherits from Kessler controller. So whatever controller you're making, call it my controller or fuzzy controller or whatever it is, you would define that here and inherit from Kessler controller. You have to do this. We are then, we have our init. You can set up whatever you would like here. One thing to be aware of, though, is that this is instantiated the first time. The init is only called the first time that you're running a scenario and running a game. And we've had issues in the past where if we are evaluating multiple scenarios, let's say we have a list of games that we are just iterating through, we are only instantiating the controllers once outside of that, the way the current competition script is set up. And so this init needs to be such that it is it has the ability to reset essentially for a new game. It has to be able to identify that it is in a new game. And I'll talk a little bit about that more later or go into more detail. The next method in the class, it has to be named this actions. This is in the base class, so you're just going to be modifying this. This is where you're actually taking in the game and ship state information and then outputting your actions to your ship. In this example, we're just setting constants for our outputs to our ship. We're just saying thrust is this constant value 50, turn rate's -90. We're going to shoot every time that we can. So fire is just true. And drop mine is false. So we're not dropping any mines. And then that just gets returned and processed by the game. You can also define the name of your ship. In this case, it's just called test controller, but this is where you'll add the name for your agent. And we also have this other method, which we're currently not using, but you can if you have a custom sprite called custom sprite path. And if this is defined, you will just pass the name of the graphic, and you just have to make sure that the graphic that you create is in Kessler game graphics images, and then you would put your ship graphic in that folder in images. And then you can just call it from here, and it'll instantiate that when it runs the game. Okay, so that's a basic rundown of the test controller. Let's go ahead and take a look at the scenario test. So in this, we're both defining a scenario, then we're instantiating a game with certain settings, and then running that game and getting scoring information back. So we're grabbing from the game, we're grabbing the scenario class, the Kessler game class itself, and graphics type. And then we're also importing our test controller that we just looked at from this other file. So the scenario that we're creating, we are creating this test scenario, named that. We are specifying the number of asteroids, which is 10, meaning they will be 10 randomly generated asteroids somewhere in the map. We don't care what they are. We don't care their direction or speed. And also, we're defining a single ship state. So this is a list of dictionaries where the dictionaries have these different values for the initial conditions, including the position of the ship. So, this is just X and Y Cartesian coordinates of where the ship starting location is. This is the initial angle and the number of lives that the ship will have. Lives is analogous to hits because if anything contacts you, it takes a quote unquote life. The team that you are on, these are just integer values, 1, 2, and the number of mines that you start with, in this case 3. We're also defining the map size. This is unlikely to change. I recommend just leaving it at 1,800. The time limit, the ammo limit multiplier that we mentioned, if you set this to 0, by the way, 0 means that you have unlimited ammo. If you set this as a positive float value, that will be the ratio of the total potential number of asteroids, the number of bullets that you get. And then stop if no ammo, we're setting that to false. So we just want it to continue. Even if you run out of ammo and all you can do is fly around, we want to keep going. The game settings, this is a dictionary with a bunch of different settings. You can go take a look at all the different options for this. But the main things are we have a performance tracker that has information about the game, including timing. We have the graphics type. This is the default, which is tkinter. We also have Unreal, and then no graphics is an option here. And actually, if I open this up, we can see those here. We have no graphics is one of the options. Unreal Engine is another tkinter. Currently, PyPlot, I would not recommend using. I believe it's non-functional at the moment. But also, if you make your own graphics, which is fine by us, you don't have to use ours during training testing. And in fact, some teams in the past have made their own graphics in order to do things like investigations into their controller's performance. And so you can make your own and then just call it custom. And you can take a look at that in the graphics handler files. Real-time multiplier, this is just how fast the game will run relative to real-time. So real-time of 1 is running real-time. You can run double real-time with 2. If you want it to run as fast as possible, you would put 0. So that's the difference there. Graphics object, don't need to worry about that currently. There's some specifics based on the graphics type, which we can get into a little bit later. And then frequency, this is basically just the hertz that the game runs at. So hertz being number of frames per second. So in this case, we're running at 30 FPS. You can change that. We will likely be changing this to be 60 FPS for the competition. And because we're dealing with discretized info, discretized game state info, the behavior can change slightly if you change the FPS, especially with things like collision checking, just because of how far things can move in a single time step. So we'll likely be changing this to 60. So training at 60 is probably a good thing to do. So after we define our scenario and our game settings, we can then instantiate a game. We're going to call Kessler game with our game settings so that it creates our game object. And then we are going to actually run the game. In this case, we're getting some timing information, but we're going to run the game with the method.run. And the things that you need to pass are the scenario that game is running and the controllers that are controlling the ships in that scenario. So in this case, we're passing our test controller that we're grabbing here, and note that you do need to have the parentheses here in order for that to operate properly. So then we run that, and what we get back from the game is the score for the game and also the performance data, because we had this performance tracker thing on. And so you can get back various information from the score class, like the stop reason, like what happened. Was it because I ran out of ammo? Was it because everyone died or we hit the time limit? You're also getting back things like the asteroids hit for each team. So in score.teams, this is where it holds all the scoring information. So if you want to see the actual score, which normally for scoring, we are just considering asteroids hit to be the score. You can go to score.teams and then look at the number of asteroids that each team hit. You can also see the number of deaths, the accuracy for each team, and things like the mean evaluation time. So this is this is how you will create scenarios, instantiate your controllers, instantiate settings, and then run games with all of those things and get information back about the game. So we can actually run this and see what it looks like. For our test controller, we're just having a constant turn rate, constant thrust, and we're just firing every time step. So if we actually run this scenario test, what we'll see is our ship barely moving because it's a relatively small thrust, but we're spinning because we just have a constant turn rate, and we're just shooting every single time step. So this is the maximum fire rate that our ship has. And you can see bullets left is -1. And that is because we put the ammo limit at 0. So we have unlimited ammo in the case. And we're not dropping any mines. So all we're doing is just sitting here, barely moving and shooting. Let's say that we wanted to change that. Let's say we didn't. Oops, sorry about that. Let's say we did want to change our thing, so it does drop a mine. And because this is always true every time step, we'll still only drop mines every time that we can, because there is a cooldown period. So let's set thrust a bit higher. Let's set it at, we'll say 200, and run this again. So we should see the ship moving a little bit more, and also dropping mines as it goes. So it's dropping mines, it is flying around and shooting everywhere. So this is a pretty basic test. Our controller is very stupid. It's not taking in any information from the game. It is just doing the thing. It is just doing these things always. And so what you're going to do when you create your controllers is you're going to take all of this game state information and the ship state information, and you're going to process that and do whatever methodology you want, including machine learning or anything else, and then use that information to then map that to actions, deciding when and what to do for your output actions. So those are the main things for Kessler, and what you're going to be doing throughout the competition. You're going to be creating your own controller, and then you're going to be doing things like creating a whole bunch of scenarios to train and test it over. And essentially what you can do is you can create all these scenarios, and then you can just have a list of these scenarios that you iterate through and get all of and run the game. Let's say you had a list and your, let's say, scenario list. And we only have the one scenario at the moment, but let's just say, imagine they're different. And what you can do is, you can say for scenario in scenario list, we want to evaluate the game. So we're going to call the game with each of those scenarios. And then, controllers will be whatever your controller is that you define. And if it's in a machine learning process, your machine learning process would be changing your controller parameters. So you'd be passing the current version of that controller in your machine learning process here and running through all of your scenarios and getting all that score data. And then based on that, you change your parameter updates in your machine learning process. We'll get into this a lot more in the subsequent talks where we're talking about how to actually do machine learning and other things in the game itself. The focus here is just on how you do the basic things in Kessler. So that's pretty much it. That is a rundown of Kessler and how you create your controller objects, how you create scenarios, and how you instantiate those scenarios and run games with all of that. So now that we've seen Kessler and how to use it, we do have a milestone. This is a mandatory milestone. And all we need from you is the associated files to just make sure that you're on track and able to actually do things in Kessler effectively. So what you're going to do is you're going to create new scenarios. You can use that example script. There's a couple of different ones. There's scenario test.py, which we were just looking at. There's also scenario test multi, which this one is essentially the same. But in this one, there are two separate controllers. So there's two different controllers that are being instantiated and used for two different ships. So you can use either or. They're both fine. And what you're going to do is you're going to make scenarios for each of the following conditions. You're going to have stationary asteroids near the four corners of the map, and your ship is going to be in the middle in any orientation. You're then going to make another one that has asteroids in the four corners that are moving towards the center, and your ship is in the middle in any orientation. You're going to make one that has two asteroids, one size 4 at the top of the map and one size 2 at the bottom of the map. They should both be moving towards the center where your ship is pointed towards the bottom asteroids. Your ship is pointed down. And then make another one that has 20 randomly placed asteroids with random speeds. You don't have to specify speed. If you just do the num asteroids equals 20, that's basically all you have to do there. And your ship can be in any location you like in this one, in any orientation. So you're going to make those 4 scenarios. Then you're also going to make a new controller class, and you can base it on the test controller.py. You can call it whatever you want, like my controller, doesn't matter. But you remember that you have to inherit from the Kessler controller class. If you're unfamiliar with inheritance or other Python object-oriented ideas, you can check out some of the examples for Python inheritance at this link. There's also a lot of resources out there. You don't have to go here. You can literally just Google it. So after you do that, you're going to create a method / function in your class. So like we have the actions method, you're going to create an additional method, call it whatever you want, call it like game state processing or information processing or something like that. And that is going to take in the game state object, and it's going to process that information to use in some way. So for example, maybe you're going to create a function that identifies the closest asteroid. So it goes through the asteroids and it finds the closest one. That's just an example. You can do whatever you want. Maybe you can find the fastest moving asteroid or the asteroid with the highest kinetic energy or whatever you care about. Maybe you want to find, yeah, I'm not sure. That's up to you. Those are just some examples. And then what you're going to do is in your actions method, you're going to call your new function, and you're going to have your ship just move and shoot based on that information. So let's say that you did create one to find the nearest asteroid. You're then going to say point towards it or move relative to it in some way. And then you're going to move backwards and shoot, something like that. We don't care what you're doing as long as you are doing it based on the information from that function. And then you're also just going to drop mines, and those mines can be based on whatever game state information you want. It can even just be based on time. And so really what this is doing is, this is your hello world into using Kessler for developing controllers. So you're just going to do some really basic stuff. And then you're going to submit this to us. I believe we have on the timeline, we have it set for next week. Let's take a look. Oh, the updates didn't get put on the website. Sorry about that. We definitely did the updates, but they must not have gotten pushed to be published. I'm sorry about that. We'll get that updated. But I believe the timeline said it was next week. So yeah, that is Kessler and how to perform the basics. And we're looking forward to seeing everybody's solutions. Thanks.